We know how to construct a 95% confidence interval for the population mean, so we ought to be able to adapt that process to construct a confidence interval of any confidence level. So in this particular interval, 95% is the confidence level. So how does the confidence level affect the confidence interval? Well, it's not affecting the sample mean. The sample mean is just whatever the average you got in the sample. Sigma and n are constants. It's not affecting that. So the thing that it's affecting is how many SDs on either side you go. That your level is affecting the amount of wiggle room you're giving yourself, the number of multiples of sigma over root n you're going on either side. And so you should see how this stuff is written in general. If you want a some percent confidence interval, and it might be a good idea to fix an example in mind. So if you are interested in an 80% confidence interval, then what are you going to do? Exactly the same thing. You're going to start at your sample mean, that's your center, and you're going to give yourself some wiggle room, and the wiggle room is going to be some number of multiples, which will depend on your confidence level. I'm going to call it z lambda of sigma over root n, right? And that's the thing that we have to find. So this lambda will affect the z lambda. So how do we find it? Well, we're going to look at the standard normal curve. There's 0, there's z lambda, and there's minus z lambda. That is not very symmetric at all. Let's try that again. Drawing is always a nightmare. All right, let's try that. Because you're trying to get drawing to look reasonably accurate. Right, there's 0. And let's give ourselves a confidence interval from there to, oh, is that better? Slightly. There. Now, the defining property of this confidence interval is the confidence level, that's lambda. And that's this area here. And so in here you have lambda percent, right? So 80%. And that is a proportion p, so lambda equals 80 means p equals 0.8. That's what I mean by proportion. So p is lambda divided by 100. You'll often see factors of 100 floating around when you read theory about confidence intervals. Okay, so you have a p there, and you want to know what z is. Well, how are you going to find z lambda? You're going to have to use your either your normal table or your statistical system, whatever it is, and that tabulates phi. It tabulates the CDF and the inverse of the CDF. So it helps to note, in order to find that z, you have to know all the area to the left of z. And so for all the area to the left of z, you also have to take into account this portion, which isn't in your p, right? It's additional, and it is 1 minus p is both tails. This is one tail, and so it's 1 minus p over 2. And so what you've noted is that this z corresponding to your lambda has some properties. You defined it by the area between minus z lambda and z lambda, and that was lambda percent equals p, right? And from that we concluded that if you look at all the area to the left of this point, not just stopping at minus of it, but going all the way out to minus infinity, that is that gold p plus the green 1 minus p over 2. And therefore, a completely formal statement is that this z lambda is phi inverse of a little bit more than p. It's p plus tail. So you can find your the number of SDs you want to go on either side, and so you can construct your confidence interval. And so, for example, if lambda was 80, then the two tails together are 20, and so the green part is worth 10%, and so z lambda is in fact the 90th percentile of the standard normal curve. And you can find that by taking phi inverse, or in Python stats.norm.ppf of 0.9 will give it to you.